partition was partition was to separate the images into 4 quadrants. So this was the right quadrant, left quadrant, upper part, and the lower segment. This was for the Cohen-Carnere data set, while this was for the FERG DB data set, the animated. And then subsequently, we further partitioned it into smaller quadrants. So this was the upper right, upper left, lower right, lower left quadrant. And same with the other data set. The objective of the research was to identify the various effect states from these small segments of the face, even when it undergoes a lot of spatial degradation. Now, reduction in spatial resolution. The CK plus and the FERG datasets were modified by reducing the spatial resolution in order to evaluate the effects of drop in spatial resolution and on the performance matrix. The resolutions that we reduced, the reduction was 256 was 256, 150, 100, 50, 225, and finally 10 cross 10. This reduction of spatial resolution was carried out on full face as well as half and quarter segments of the face. Now, these are the images that we have done using spatial resolution. So these are the original images, which are of size 256 cross 256, while these are the lower resolution images. Now, just to understand the amount of degradation that has happened, this image, the first image and the last image have been compared. So this is 256 cross 256, 150 cross 150, 100 cross 100, 50 cross 50, 25 cross 25, and 10 cross 10. So this is the amount of degradation that happens that we have been able to simulate. Now, along with this, we have also done spatial resolution drop in the half segment face images as well as the quarter segment face images. So this is the right half of the image, and this is a 10 cross 10 image of the same image, whereas this is a lower right segment of the image, and then subsequently we are reducing the spatial resolution to get a 10 cross 10 image. So we can understand how much has there been a drop in the spatial resolution. Now, the proposed methodology. Deep learning is one of the most common machine learning approaches which aims at teaching the computer to take decisions by example. Deep learning models are known to achieve state-of-the-art results which can exceed human performance. We have used 3 different networks. One is called the Spatial Exploitation-based CNN. The second is Depth-based CNN. And the third is Channel Exploitation-based CNN. And we have fed all these images through these 3 networks. So this is the first one, which is Spatial Exploitation-based CNN, in which we have used the VGG network. This is the VGG network, and this is the structure of the VGG network. It has 16 layers, and it has a non-active linear activation function called the ReLU. We have modified the last layer to suit so that it works for our data set. The second network that we have used is called the depth-based network. Now, deep CNNs have layers that run deep, because of which back propagation of error results in small gradient values at lower levels, hence making the network difficult to train. Thus, the main problem of deep networks is slow training as well as low speed of convergence. In this, what we have used is we have used a residual network, that is ResNet 50, which has 50 layers, and it uses a shortcut connection so that this whole problem of low speed convergence is taken care of. This is the structure of the ResNet, wherein you see there's a shortcut connection, and this is the basic structure. It has 50 layers, which consists of max pooling, convolution, batch normalization, ReLU, and so on. And the final layer is, of course, the softmax layer. The third layer, the third network that we have used is called the Channel Exploitation-based CNN. Now, this network uses a new architectural block known as a squeeze and excitation network. Right? The objective of this is to improve the quality of representations. The proposed new block selects only specific features, maps known as channels, which are relevant to object detection and classification. The role of the SE block, that is a squeeze and excitation block, is to assign high values to certain feature maps and suppress those which have less amount of information. In our study, we have used a ResNet, and we have incorporated a channel exploitation network inside the ResNet model. So this is the residual block, the ResNet, and in this we have used the squeeze and excitation network. So the SE block in ResNet uses global pooling operation, which is a part of the squeeze phase. And this is followed by the excitation phase, which consists of two fully connected layers with RAID. Right? We have used an RMS prop optimizer to increase the learning rate. We have used a categorically cross entropy loss function and a softmax classifier. This is the general block diagram of the system that we have used. So you have input images, we perform face extraction, we do pre-processing, we partition the data into half phase segments and quarter phase segments, we perform reduction in spatial resolution, we do class encoding, we split them into training and validation set, and then we give them to the CNN architecture block, the three different architectures that we have discussed. We have a softmax classifier, we use a loss function and an optimizer, and this is the back propagation. Now, the following experiments were carried out on the 53 data sets. CNN on full phase unoccluded images with reduction in spatial resolution, CNN on half phase segments with reduction in spatial resolution, and finally, CNN on quarter phase segments with reduction in spatial resolution. The proposed networks are trained and tested, keeping the data is shuffled. The image batch size, which is the number of training data used, was set to 32. The learning rate is 0.001, and a total of 25 epochs were run. We have used the following performance metrics. One is precision, we have used recall, and we have used F1 score.
Mr. Dhananjay, sorry for interrupt.
Yes.
Yeah, please conclude this. Actually, their time is limited to 10 minutes for presentation.
Okay,
yeah.
I'm sorry. Yeah. So what I will do is, so these are the results that we have achieved. So I will not get into the results. We have compared the results with the existing techniques, and we have found that the results that we have obtained are high. So these are some of the results. I will simply summarize the. Okay, I'll take 2 minutes. Summarize the three proposed methods were compared on full face and unoccluded images. We compare the results. From the work carried out, it is evident that all 8 segments of the face carry information during emotion elicitation, and the proposed networks can identify these expressions even under low resolution images. We have successfully shown that half and quarter segments of the face give high performance matrix even when there is substantial reduction in spatial resolution. Exploratory findings through this research have yielded new insights and can be used in a variety of future applications. This is the conclusion. Right? I'll mention the last 2 conclusions. The result obtained confirms the position that accurate effect detection can be achieved from low resolution small segments of the face. And finally, the work carried out to understand the relationship between spatial resolution reduction and recognition rates establishes the position that deep learning networks proposed in this paper give high recognition rates even for low resolution images. From the results discussed in the paper, we conclude that even when the human computer interface system has access to entire frontal face images, only a small segment of the image is required, and results are not affected by reduction in spatial resolution. Thank you. These are my references. Thank you for giving me the opportunity to present my paper.
Any query from the session chair?
Good morning, Dhananjay.
Good morning, sir.
This is Professor Ramesh. You presented nicely. Let me have some basic questions. So whatever results you achieved, can you compare with the existing? Because we have so many things as on today. And what is the existing accuracy and how much you improvised? Can you just show?
Yeah, I will just show you that slide. See, these are the results that have been mentioned in the literature for the varying resolutions, and this is on full face images.
No, as on today, the existing techniques, correct? No?
Yeah, these are the existing techniques.
How much you improvised? How much?
Yeah, so this is what we have done. Just a minute, So this is what we have achieved. So so the existing techniques.
How much improvisation you made? Can you tell me in terms of percentage?
Yeah, so this is what it is. So this is our result. So for the first network, for a 10 cross 10, we are getting 60%, 93%, and 98%. Whereas the existing literature gives us in the range of 79 to 72% for very low resolution images. And this is the graph that has been plotted. So if you look at the
79 to existing one, 79 to 6. That's what, no?
Yeah. So one of them has also got 90. For example, reference number 38. for a resolution as small as 18 into 24 has got 90%, while we have got something close to 98% and 93%.
This you got with respect to amount of data you collected?
Yes, all these are basically using the CK plus dataset. CK plus is a standard dataset that is used for expression analysis. So these results have been achieved for the CK plus dataset.
Okay. And next question is that you, because we have plenty of algorithms, deep learning, right?
Yes.
But you selected only 3.
Yes.
Correct. Why? On what basis? What is the justification?
Okay. Yeah. The first network that we chose was the SEB dataset, which had 16 layers. Right. So we carried out our work on 16 layers, and we realized that it works well when the resolution is good. However, there's a drop in resolution as we go on, drop in accuracy as we go on reducing the resolution. So the next obvious step was to increase the number of layers. So we took the depth-based CNN, which has 50 layers. And we realized that the depth-based, which has 50 layers, works much better than a network which has 16 layers. And then we saw that if we wanted to improve it further, we thought if we could, work on channel-based, wherein, importance is given to feature vectors which are important. That's the reason we use the next layer, next network, which was the channel-based network. And we have seen a marked improvement in the low resolution accuracy.
No, you are telling just only on the theoretical basis, or you have done any mathematical groundwork based on this? This is what I have selected. Can you say like that? Or you say just based on theoretically you are selected, or you say mathematically I have justified, so based on these factors I have selected?
No, I did not mathematically do it, but these networks are available, right? Okay, so we took a network and modified the last layers, and then gave our data. But mathematically, we have not.
If you done very mathematically, I think that is a strong justification, right? That will be
okay. So I will work into that.
Okay, Dhananjay, thank you.
Yeah, thank you so much.
Yeah, Dr. Dhananjay, this is Dr. Tiwari. So yes, your work is really good, I must say. Okay, I have just one the query like that. You have used Viola-Jones algorithms to identify the faces. So the data set you have shown, already there are faces. So what is the much use of Viola-Jones algorithms to find out the faces inside the faces like that?
Yeah,
there may be some outlier, some background is there, but all the data set already with the faces only.
Yes. So
the data set you have shown over there.
Yeah, you're right, sir. So basically, all these data sets are face data sets, but the data sets have some information. For example, the date in which the image was captured. What is the expression? So if you look at this image, so you'll have some time map on the image. You'll have some date on the image. So we did not want this to be fed into the network. That was the only reason we used the Viola-Jones algorithm, to remove any background information that would be there in the data set. But what you're saying is right.
Yeah, thank you. Yeah, just for my learning purpose, I'm asking.
Yeah.
Like the other data set, like the having the full body, hand, leg, and full body maybe there.
Yes.
So can we use the Viola-Jones to find out the faces and use that output of the Viola-Jones as input our algorithms?
So a Viola-Jones algorithm will identify the face even if there is a whole body, and if it's an outdoor, even then the Viola-Jones algorithm would identify the face and extract the face.
In that case, manually we have to labeling the class's name and all those things, I think.
Yes, in that case we will have to manually label what is the kind of expression that is there. But face extraction will be done by the Viola-Jones algorithm.
Yeah, thank you from my side. It was good work. Thank you.
Yeah, thank you, sir.
Okay, so thank you very much for this work and presenting this work. So specifically, I do not have any comments, but I have some suggestions based on the observation, and I hope that will be certainly helpful.
Definitely.
So the first point here, because you are aiming for deep learning based methods, I think in future you should look for bigger data set. And because the data sets that you presented, where you have 2,502 in number of images in CK plus for training and 2,781 for this FERZDB data sets, I think somewhere is relatively lower.
Okay.
You have to look for the data set, and it is better if you are working in this area to create new data sets that can be at least having 50K images or 60,000 images, then it will be much more beneficial.
Okay.
This is the first point. And the second point is when you have done this partitioning, you are still retaining the rest of the images in the black portion. That might not be good because it may lead to some biasness. So why not to remove that part and then just test with the remaining part? Right? That is another suggestion. And next suggestion is, though you have showed this results comparison, but these methods that you have used for results comparison, those are outdated methods. In present scenario, you have to look for the recent methods for the comparison as well. If you are looking to extend this work in the future for some better conference and journals.
Okay.
And even from network point of view also, I could not find anything new because even many students are simply using these networks for different applications like this VCC, and these things are very common nowadays. And another important thing, in especially for this expression recognition, if you can explore in future the concept of something called saliency or attention. So attention is gaining a lot of popularity where it can automatically figure out which particular reason to focus on better. So instead of doing partitioning, even if you have entire image as the input, it can better figure out automatically. So that's what is a new trend in this particular area. And from training point of view also, I feel that the number of epochs that you have used for the training is little low. Even I think you should train it for longer, because I think it was 25 epochs, and
yes, that's right.
that is not sufficient. You should train at least for 100 epochs. By lowering down the learning rates, then your model can better convince.
Okay.
Yeah, so these are only the suggestions from my side, and I hope it might be useful to you in future.
Yeah. Thank you so much. Thank you. Thank you so much.
Thank you, Dhananjay, for your nice presentation. So
thank you.
Now,
I will stop sharing.
Yeah. Yes, please stop. Now I invite our second presenter, paper ID 122, Mr. Vineet Goyal. Vineet, are you there?
Yes, sir.
Yeah. Now you are.
Yes, I'll share my screen.
Yes. Please share.
Or is my screen visible?
Yes, visible. Go to full screen and start with presentation. Yeah. Okay. Yes.
So good morning, everyone. I'm Vinod Goyal. I'm a student at Indian Institute of Information Technology, Pune, and I'll be presenting our paper ID 122 texture classification using ResNet and EfficientNet. So this is the flow that I'll be following to present the paper. So first, the background. So the texture is the fundamental unit of an image. It aids in its identification. Analysis of texture forms the fundamental basis of computer vision tasks like image recognition and image segmentation and other various tasks. Images of various domains like satellite and medical have been identified because of their texture. It is a crucial aspect of computer vision. Over the years, many developments have been made in proposing model algorithm for texture classification. So this is the literature survey that we did. So one of the earliest papers to do texture analysis used two powerful algorithms, principal component analysis and multi-scale autoregressive model on the Brodach dataset. This approach was later followed by energy-based models, which attained the accuracy of over 90%. One of the earliest methods used for texture classification is the statistical method. They make use of powerful feature extractor descriptors. They are the simplest and yet powerful algorithms. There have been many descriptors proposed. Some of the most widely used ones are local binary pattern, local ternary pattern, completed local binary pattern, and completed local ternary pattern. Traditional machine learning have got great results in past. However, they have the disadvantage that these feature extractors need to be handmade. Since the feature extractors are hand designed for a particular problem, they fail to generalize or adapt to another data set. Deep learning models overcome this problem. One of the papers proposed an 8-feature learning model alongside a deep learning perceptron-based architecture. This paper showed that deep learning models advantage over the other models. Another method was a descriptor called the FEAT-WC-LTP descriptor. They tested that descriptor on various datasets, including the Kilberg dataset, and got competitive results. Another method proposed a multi-threshold corner detection and region matching algorithm based on texture classification to solve the problem of unreasonably dispersed corners in single threshold Harris detection, as well as the high computation cost of image region matching using the normalized cross correlation approach. Another method proposed an approach to classify where they use the Whale optimization algorithm along with convolution neural networks. Results of this model on the Kilberg, Brodach, and Outtext datasets were compared, and the results obtained by other models were compared. So this is a problem description. We want to do a brief literature survey on the different approaches used for texture classification, and we want to implement some pre-trained models on state-of-the-art datasets like the Kilberg dataset and check the results and compare them. So this is the methodology. The dataset that we use is the Kilberg dataset, and here is a brief summary of the dataset. The second step was data pre-processing and splitting. So for all the pre-trained models, the models require an input image of 224 into 224 into 3. So all the images were first made compatible, and they were resized to 224 by 224 by 3. And then the data set was split into a ratio of 80:20 into training and testing data set. Third was data augmentation. So data augmentation is the process of creating more data from already existing data by flipping the images, rotating the images. So we use data augmentation to create more data. The fourth step was the choice of models, pre-trained models. So we chose the ResNet-P2 model and the EfficientNet-P4 model. And the evaluation metrics that we use are precision, recall, F1 score, accuracy. So all the papers that we saw on Kilberg dataset previously only used accuracy to determine their models, but we have also used precision, F1 score, and recall. And these are the results. These are the graphs and the table for the ResNet-P2 model. And these are the results and graph for the efficient P4 model. And performance. This is the performance comparison table.
I request all the participants, please mute your mic. Yes, please continue.
So here we can see that our model has marginally it has outperformed the other models, and it has gave really competitive result, the ResNet-P250 model, and the EfficientNet-P4 model has also given some competitive results. So in conclusion, as stated, texture classification is an important area of research that has attracted a lot of research and models. From the comparative study, it can be seen that our models have given better results than most of the existing models for the Kilberg dataset. And these are the key references for our paper. That's any questions?
Any query from the session chair?
Good morning, Vinat.
Good morning, sir.
Please go back, go to references on papers. Which year you referred the papers? Can you show me this?
Yes, sir.
See here, 93 and any paper you referred into 22 or sorry 21.
Sir, actually more the data set that we chose is the Kilberg data set, and when we checked, so on that data set particularly not much work has been done in the past few years. The latest work,
what I say, whatever you say, that is with respect to latest kind of things, because in the matter of 6 months we see a lot of changes, correct? Na? In terms of technology, techniques, in terms of results.
Yes, sir.
My suggestion to you is that always you have to justify whatever you achieve, the results with respect to the latest one. So maybe I don't accept, you said, I didn't find. Maybe my suggestion, you have to do much more drilling, the latest kind of things. That is one aspect. Okay, you have to
sure,
see.
So we'll look into it and we'll find some
because
more
anything you want to say something new, always in the matter of maybe 6 months, 1 year, you cannot go beyond that, because in a short gap of 6 months, we see a lot of changes, correct? No? So then
Yes, sir.
whatever we achieve, then it is very difficult to substantiate. Then tomorrow people should not say this already done. That should not happen. Okay.
Yes,
So
sir.
that is one thing. So literature survey is very important. Please look into that latest kind of work done with respect to your work. Please look into that.
Sure,
Okay.
sir. We'll do that.
And secondly, please go back to your results graph. Whatever you got, please can you? If you got a nice graph. What is the inference you made? What I can understand from the graph, first one. What do you say?
So the first graph is the accuracy versus ecograph, and the second one is loss versus
What is the accuracy you got there? How do you correct? What is the accuracy you got? How to measure accuracy from that graph?
So I didn't measure the accuracy from the graph.
That is very important, correct? Now, whatever graph you say, that should be very clear to the audience. Okay. So how much you got? Can you say how much? Can you measure from the graph? How
No,
much
so
you
we
got?
can't measure from the graph.
Then
so I did
there is
it
no.
separate.
Suppose if you are not able to do that, then it's no point in showing such graphs. Correct? No. So whatever you show, I think that should be very meaningful. So we should understand it. Okay?
Yes, I understand that.
You have to inference from the graph. That is, I think that reflects your work, na? Correct, na?
Yes, sir.
That is your work. So I think that should be very clear. Okay.
Yes,
so please look into
that.
these kind of things. Thank you, Vinath.
Sure, sir. I will look into it.
Yeah, Smith, I have just some couple of suggestions. Like you can include the more data sets. Like you have, I think you have used a single data set. So if there is available, go with the more data set. And you have pointed out the deep learning methods have a capability to extract the important feature by themselves. It's okay. But for improving the accuracy, you can also help model by doing some pre-processing. So I didn't find any kind of pre-processing on the images you have carried out to push to help the further deep learning models to find out the better features. So that are only my suggestions. Thank you.
Yes, sir. I'll do that also, sir. I'll also try to extend the study and do some pre-processing.
Yeah. Thank you.
Thank you for the suggestion, sir.
Okay, so I think you need to work a lot, and your work is at very primary stage, and I think even it is not in publishable form, though you are getting the paper here, but things are not on that par as it is required to be published in conferences like MISP. And when I'm saying this statement, there is some reason behind this. The first reason is this plot itself that you are showing right now. So here you can see either it is first plot or second plots, your loss is still going down and you have just stopped at 10 epochs. That is not correct, right? Your training is not converged it and you have stopped it. And this is one thing that you have to take care. And if you go to your results comparison, then this results comparison is giving a lot of indication, and that indication it means that the data set that you are considering is not a challenging data set. Means almost all the methods are achieving 99.4, 99.64% results. Then what is the scope of improvement? There is very less scope of improvement. It means that this data set is not challenging, and in fact that is true also, because the data set that you are considering is a small scale data set, and because that is a textured data set, it is having repetitions, so it is going to be very easier task for DL methods. So you have to look for the challenging data set. So for example, there is ALOT data set which has 25,000 number of samples. You consider that. And another important thing,
Hello. Hello, I am audible.
An appropriate feature extractor. This is very, very important, because as I have told you that they are low intensity, the data set is limited. So for this issue, the researchers are proposing the new feature extractor techniques, specifically keeping in mind the ME characteristic, those 3 characteristics which I have told you. And what they are doing, they are modifying the existing feature extractors as well. Second is the limited data set samples. As I have mentioned here, 5 data sets are available, publicly available till date. That is CASME, CASME2, CASME Square, SAMM, and SMEC.
Good morning, Dr. Loh.
And in this category, only few samples are there. So that's why we need more samples for this data augmentation techniques are adopted. And researchers are also using the temporal interpolation module. So they are introducing some frames in between the original video sequence. And third one is the handcrafted features that requires great understanding, because when we compare it with the deep learning technique, so in deep learning, CNN are automatically intercepting the features, but in handcrafted, first we need to understand that how the micro expression is looking and how we are going to extract those features, which area we need to focus on. So this is the issue. So for this, the researchers are focusing on prominent area of the face region and fusing 2 or more feature descriptors. Fourth is recognizing ME in natural or wild scenarios. So till date, all 5 data sets are recorded in a confined lab environment. So there is no such task to detect the micro expression in natural scenarios. So for this, there is a lots of pre-processing is there, or we need to emphasize more on the data pre-processing step for recognizing ME in natural or wild scenarios. So the conclusion of my paper is that we know that micro expressions are spontaneous and involuntary in nature. So the handcrafted and deep features method both are performing well for ME analysis task, but the specific, when we are talking about the handcrafted features, so it requires in-depth understanding of micro expressions. Whereas for deep learning techniques, so the shallow CNN works fine for ME analysis, because as I've told you, there are very limited data samples. So a few layers of convolutional neural networks are sufficient to extract the features. And one more thing, appropriate kernel size selection is important, because researchers are constantly showing that if you are going to select the 11x11 filter size for convolutional neural networks, so it may miss the tiny expression presented on the face. So that's why appropriate kernel size selection is important. And at last, the deep learning requires use data. So for that, we need to look on. This is the future research direction. So first is again to create new data set or extend the existing one. Second is the develop new feature extractor for spotting and recognition. Now some researchers are also exploring the compound micro expression, that is happily surprised or sadly angry. So they are occurring on the face together. And some application area for this micro expression analysis is in deception detection, criminal investigation, or the children engagement during an online class, or the any activity. So this is from my side. These are the references. And thank you for listening.
Any query from the session chair?
Hello.
Yes,
Good afternoon, Ankita.
Yes, sir. Yes, sir. Good afternoon.
What I say, by seeing your presentation, it is very, very preliminary, this one. Okay,
Yes, sir.
it's a study. I think
Yes, sir.
we cannot make it as a kind of research work here. I didn't see any kind of what I should say work is involved. Only it's a theoretical concepts. Okay.
Yes, sir.
Are you doing a research work or what? Are you still in the beginning stage?
Sir, I'm not at beginning stage right now. At least 2 years has been completed, and right now I am working for
but in this paper, in this presentation, I'm very
Mhm.
sorry to say I didn't see any kind of what I should say work, results, implementation part, design
Yes,
part. I didn't see. Okay,
yes.
it is very plain paper. Okay, very
Mhm.
plain. You think of I didn't see even the specification. What are your specifications? Your work specification, your objectives. That is
Sir,
very important. See, what
okay,
is your
sure.
objectives? With respect to your objectives, what is your proposed methodology? What kind of algorithm you have chosen? Why? On what basis? Okay. And with respect to that, how much you achieved in terms of, I say, result in terms of performance, how much accuracy you achieved, I think that is the kind of work we want to see here. I think I didn't see any kind of these things. Okay, it looks very generic. Think of more of technical aspects with respect to your objective, what you want to. Okay, I think that is completely missing, Ankita. Just look into that.
Sure, sir.
And also, if you see your papers, what you showed in the references, all very, very old one. So I told you in the previous researcher also, I think that is not the way. If you want to substantiate any kind of things, that is must be with respect to latest. What is existing today? Please understand what is existing today and how you are going to improvise. That is very, very important. Please understand. Maybe you are improvising in terms of performance, or maybe cost wise, maybe portability. Maybe what I understood, you are looking into the performance. So as on today, what is the performance? It is, we got it existing, and definitely you are not happy about it. So you try to improvise that. That's correct, na? If you want to improvise, in what way? Okay, how much you are going to improvise? That should be very clear. If it is not there, then it is very difficult to accept it as a research kind of things, innovation. You understand? So that means to say we should understand very clearly what is existing. Please understand. If you take any existing system, any existing technology, definitely there are some positives, there are negatives. We cannot point one system only 100% advantage, no disadvantage. No, not that way. Please understand. You got my point. If you take any technique present, there are advantages, there are disadvantages, negatives are there. We should look into the negatives. So try to convert that negative into positive. Then it becomes new thing. So then we accept. Yes, it looks like a new concept. You understand? So that is where we have to focus. That means to say, what I should say, a detailed survey is very much required, a detailed analysis of the existing one. If I'm not able to do that, then I'm not able to fix the problem properly. Please understand. So whatever you say, whatever I do, somewhere we have to work on the performance. So as on today, this is a performance. I want to improvise. If I want to improvise, in what way? Please understand. So what is my proposed methodology? Maybe the performance is best. Maybe the cost wise is very high. Suppose if I want to reduce the cost, in what way I can reduce? Because what is most important, performance and cost, both should together, a trade-off. We cannot achieve both. Somewhere we have to balance. Maybe I think with respect to one, you have to say, this is what my expected result, this is what my expected specification. If I want to achieve, so what is the path? What is my direction? How I'm moving? I think that should be clear. So whatever you through the journey, whatever you got results, maybe it's a fault. Maybe we have to criticize how best I can do it. I'm going to fix the problem today, tomorrow, I cannot expect the result. But there is a journey, correct? Na? So through the journey, what are the results you got? What are the inference you made? I think that reflects your work. That reflects your quality of work. How much result you show, how much result you project. I think that is really, there is a kind of work is involved. Please look into these kind of aspects, Ankita. Okay?
Okay, sure, sir. Sure, sir. Thank you.
Okay, best of luck, ma. Thank you.
Thank you, sir.
Okay, thank you, Mr. Yes, sir. Yes, sir. Yes.
Go, please. You go ahead.
Yes, sir. Yes, sir. Please ask.
I just want to convey. Ramesh sir have covered all the suggestions, whatever I thought about. So, Ms. Ankita, you just focus on the particular direction by which you can improve the results, and now you may. Or you should start to thinking the experimental works to fix the direction and do the experimental work and somehow come with the improved result in any of the parameters you thought about. Thank you,
sir. Sure, sir. Thank you.
Okay, so thank you very much. I think many things have been already covered by Professor Ramesh and Dr. Vivek. So you try to incorporate those things and also try to include the experimental comparison and these things in the future. That will be certainly beneficial.
Okay. Sure, sir. Thank you.
Thank you very much.
Yeah, thank you, Ankita, for your presentation. Now I invite our fourth presenter, paper ID 329, Suryakant Singh. Mr. Suryakant Singh, are you there? So any co-author is presenting? Suryakant Singh, paper ID 329. Okay, sir. Meanwhile, we will move to next, and I'm just connecting with this particular paper co-author. So next paper 350, paper ID 350, Ajay Prasad.
All session chairs are also requested to keep in mind the time limit also, because the time allotted for this session is over. Yeah, you can extend 10, 15 minutes, 20 minutes, but there should be a check for time, because on the same link, next session is scheduled.
Yes, Ajay. Now you are presenting your paper. Yeah.
Yes, sir.
Share your screen and start.
How many papers are left, Venkatesh, in this session?
Sir, one absent as 329, and the last one is this.
Okay, good, very good.
Yeah.
Sir, my paper is visible now, sir.
Yeah, visible. Go to full screen and start with your presentation. Yeah. Yes, Ajay, continue.
Sir, 1 minute, sir. For me, not visible, sir.
Yeah, okay.
Yes, sir. Sir, I am Ajay Prasad from Sense Department, Vellore Institute of Technology, Chennai campus, sir. My title is on AQI framework for video services in 5G networks with supervised machine learning approach, and my ID is 350. Table of contents. First, I will go with background, literature survey, problem description, methodology, result and discussion, conclusion, references. Background. Online video streaming example, video on demand has become the most dominant application on today's internet, sir. Presently, around 82% of the internet traffic is due to the multimedia streaming. Recent studies show a predominance of video streaming traffic in foreseeable future. Example, 5G networks. At present, we are focusing on 5G networks. 5G is expected to support high throughput, low delay, contributing to enhanced quality of experience expectation. One of the key challenges in 5G is adapting to the increased growth of video streaming traffic and maintaining smooth quality of experiences. Streaming services adapt to the dynamic adaptive streaming HTTP protocol paradigm to deliver online video content. Dash also concentrates on 3 types of protocols like hybrid buffer-based and rate-based algorithms. Adaptive bit algorithm aim to detect a favorable quality of video streaming. In 5G or future network, quality of experience management is crucial to optimize better video delivery. It is necessary to understand the adaptive bit streaming algorithm behavior, the impact and correlation between the quality of experience and quality of services key performance indicators. The quality of services key performance indicators are throughput, delay, packet loss, and jitter. Quality of experiences parameters are based upon the mean opinion score and under the objective methodologies. Literature survey from the paper on a machine learning based framework for preventing video freezes in HTTP adaptive streaming. Here the concept or approach used a machine learning based framework to reduce the video freezes and freeze time. Limitation, quality of services and quality of experience matrices are not considered. From the title, a machine learning approach to classifying YouTube quality of experience based on encrypted network traffic. The concept or approach used here is dynamic adaptive streaming HTTP machine learning classifier to predict user satisfaction, which considers the network matrices such as round trip time, throughput, and number of packets. Limitation of the paper is much attention has been given to quality of experience evaluation rather than the state of art per segment quality of service to quality of experience mapping. Here in this paper, quality of services matrices are not considered to map with quality of experiences. From the title, quality of experience driven dynamic adaptive streaming multicast scheme for 5G mobile edge network. The concept
Ajay, it is better if you can just focus on the proposed part.
Okay. Sir, this is the methodology we are using. That is dynamic adaptive streaming HTTP works by splitting video files into many small segments of the same duration. Each segment is encoded with different bit rates. The representation of each segment describes the media presentation description file. Adaptive bit streaming algorithms are responsible for dynamically selecting the appropriate segments based on the current network condition. The purpose of this dynamic segment selection is to adapt to changes in the network conditions. This is the methodology the entire work we are using. Here in this work, we are using NS3 simulator. In NS3 simulator part, we are using video server, network, and user terminal. For network side, we are using 5G datasets. Video server, at the video server side, we are hosting a video with the help of Intel video server. And at the client side, we are accessing the video using dynamic adaptive streaming HTTP protocol. Based upon the packet capturing and video log, machine learning supervised algorithm is used to training and testing of the face, and final quality of experience prediction model is used to give mean opinion score based upon the excellent above average, average below average, and poor. This is the model we are using. Results and discussion based upon the mean opinion score. The data sets are divided into imbalance and balance. The result which we have occurred is random forest classifier achieves 76% comparing with other 4 types of algorithm. In our paper, we are using five types of algorithm. While comparing with other 4, random forest classifier gives 76%. Conclusion. An outline of the 5G video services framework is specified in this work. This framework can be employed in various areas of the wireless networks. The representation of dynamic adaptive streaming HTTP video streaming is in static and mobility scenario for quality of services to quality of experience correlation and prediction method based on supervised machine learning classification is done here. In this work, different algorithms are analyzed among. RFC has been opted since it has the highest accuracy of 76% in comparison with other models. Hence, in real-time scenario, RFC can be suggested to predict quality of experience, which helps in content providers and network operators to satisfy the end user's needs. These are the references I have used. Thank you, sir.
Yes, any query from the session chair?
Good afternoon, Ajay Prasad.
Sir, good afternoon, sir.
How are you?
Sir, fine, sir.
Fine, okay. You showed no proposed work in the proposed model. In the
Yes,
proposed model, what exactly your work? What is your work here?
Sir, here we are unable to get the data sets in real-time scenario, sir. For that, we are working to generate our own data, sir, by employing this kind of video server and networks and the user terminals. Based on this, we are generating our own data set and using it, sir.
What kind of data set you generated?
Sir,
because you said there is you are not able to get real-time data set, na?
Yes, sir. Yes, sir.
How you simulated that real-time data set? How you?
Sir,
what kind of data set? Can you say some specifications of the data set? What you developed? What you got?
Yes, sir. One part of data set is obtained from a reference paper, sir. One part is obtained by us, sir.
What are the specifications? Can you say what are the specifications of data set?
Sir, stall ratio, sir. Video stall ratio, playback time. These are all the data which we have generated, sir.
Can you quantify them? Can you quantify them? Can you quantify? So these are the data sets we have used for my model, and this is what we got. Can you say something like that? Why you are not able to get real-time data sets?
Sir,
correct. No,
sir,
you said
yes,
what made you to generate your own data set? Why you are not able to take a real-time data set? Are you into only a simulation part or what? Are you
sir,
just
sir, at present we are only in simulation parts.
Simulation, okay.
Yes, sir. Real-time data sets, 5G data sets, getting 5G data sets.
So okay, you got some simulation results, no? What are the simulation results you got? Are you happy with your expected result?
Sir, no, sir. At present, not happy.
What is your specified result? What is your objective, or in terms of accuracy? How much you got in simulated result?
Sir, that only, sir. RFC we got 76%, sir. While comparing with other algorithms.
No, what is your expected result? What is your expected accuracy? How much your expectation? How much you got? I'm talking about your ideal, desired, and actual.
Okay, sir. Okay, sir.
Sir, have you done any such kind of testing? Have you done?
Sir, expected is around 92, sir, but got only 76%, sir.
Why you are expected only 92? If you set the goal for only 92, why? Usually we set the goal for 100, na? Why you made as a goal only 92?
Sir,
Correct, I think that is wrong, correct, no?
Yes, sir. Yes, correct, sir.
Already 92 is there because you have to set the goal for the higher one, correct, no?
Yes,
Is
sir.
it not?
Yes, sir.
Why you set the for your expected for 90, you got 70? Why it's like that?
Sir, other algorithms are around above 90, sir. But I'm working on it, sir.
No. That please look into that, Prashant. Okay.
Okay,
These are
sir.
the
Okay,
very
sir.
basic questions.
Okay.
Because you, while setting your specification, that should be very clear. While setting your specification, that should be based on what is existing. You understand?
Okay.
So simply you cannot make 92.
Okay, sir. Okay.
So you should fix the your target properly. Okay. So
Okay.
you try to work in that direction. I think
Okay.
I'm not getting why you made it as just 92. Okay. Please
Okay.
look into that situation. Huh? Please look
Okay,
into
sir.
that.
Okay.
Okay, man. Thank you. Best of luck.
Thank you.
Yeah, Ajay Prasadji, what I could understand, you need to go with more detailed literature survey because like Ramesh asked very common and very simple questions and you are not able to answer it. It shows that you are at the beginning stage. The problem is much not clear with you. Your objectives are not clear, and somehow you have randomly set out some goals and parameters and something, and you have carried your research work. It's okay at the beginning stage, that's fine, but go with the very detailed literature survey that you help you to find out the objectives, the basic backgrounds, and help you to go and find out the real research directions. So you need to work a lot, and with the positive mind you should support it.
Okay.
Thank you.
Okay, thank you, sir.
So Ajay, I have one more question. How did you compute accuracy?
Sir, by using normalized matrix methods.
How?
Sir,
There should be some ground truth. Then only you can compute accuracy.
Yes, sir. Precision, recall, F1 score, and accuracy. And these are the
different thing. What is your target? Means target because you have already computed it. It means that you have some target that you have quantified. That then only you got this number 76. Then what was that target that you used? So generally, accuracy means you are testing for suppose 100 samples, then 76 samples are correctly tested, and remaining are not correctly tested. So it means if you're not able to answer this question, then you need to again look at what is your ground truth data first of all, and how you got this number 76. So this is one thing. And another thing is because this 76 is still low. So what is your plan? How you can improve it in future?
Sir, again want to train the models.
On this training model, I think you should have some better picture. So anyway, but you should again introspect whatever you have done, go in the details and look what exactly you have done, from where you are getting the data, from where you are getting the ground truth, and what might be happening inside this entire framework. Then only you can find out how you can proceed further, because presenting in a conference means you should also get some indication that how you can proceed further. So that's how actually research has to grow. So you should again introspect the things that you have done. So that's it from my side. Thank you very much.
Thank you.
Yeah, thank you, Ajay, for presenting your paper.
Thank you, sir. Thank
Please
you for the
unshare your
opportunity.
screen. Yeah.
Okay. Thank you.
So, is there anyone, any co-author from paper ID 329? Okay. So, participants and respected session chair, please turn on your camera. for a group photograph. Just 1 minute. Yes, thank you.
So I think we can end the session. Venkatesh?
Yes, yes, ma'am. So may I, ma'am?
So yes, you can.
Yeah. So on behalf of NIT Raipur and organizing committee of the conference, I thank you all for sparing valuable time as well as providing valuable insight to the author. So thank you, Sivaram sir, Vivek sir, Ramesh sir. Thank you so much, sir. And it is kindly requested to session chairs fill the evaluation seat so that the best paper award can be decided and finalized.
Yeah, thank you very much, Venkatesh. But in the evaluation sheet, how we will fill the form, these details of the
actually, sir, there are the rating from 3 to 10. The lowest one as a 3 and the highest one as a 10.
No, for the absent group, then we will fill 3 because it is compulsory to fill the detail.
Yeah. Okay.
Yes.
No
yes.
Okay. Fine. Okay. Thank you very much.
And my side, can I speak?
Yes.
Congratulations to all the participants for their. Someone is telling. Someone is telling.
It is not an issue.
Shall I continue, Venkatesh sir?
Yes, sir. Sure.
Let me congratulate all the participants for their effort. So definitely, always there is an improvement. Whatever we mentioned in a short span of time, whatever we understood. So take it in a positive note and move forward and try to come out with more clarity in the coming days. That is one thing. So let me make use of this opportunity, make use of this platform to say my sincere thanks to Dr. Dilip Singh sir, Sisodia, for his fantastic job. Organizing this kind of workshop is not easy. I have seen personally. My personal thanks to Dr. Dilip Singh Sisodia sir. And really, it was a nice platform. So I got an opportunity to sit with other great personalities, Dr. Shivaram Dubey sir. My thanks to Shivaram sir, and Dr. Vivek Tiwari sir. Thanks a lot. And it was a nice experience. And definitely we look forward to this kind of assignments in future. And even I should say thanks to Venkatesh Gauri Shankar sir for your help and support. I started calling you from yesterday. You helped me a lot. Once again, thanks to Dr. Dilip Singh sir and Sonal Yadav. Thank you. Thank you all.
Thank you, sir. Thank you.
Thank you, sir.
Ramesh and all.
Dr. Shivaram Dubey, Dr. Vivek Tiwari, Dr. K.V. Ramesh. Thank you very much for spending your valuable time and conducting this session.
Thank you, sir. Thanks a lot.
Thank you.
Thank you all.
Thank you, sir. You are running short of the time.
Thank you.
Thank you, sir. Thank you so much, sir.
Thank you.
Ram sir,
Vivek sir,
my best
you are also requested actually one keynote talk scheduled at 4 to 5 p.m. today.
Okay.
So I would like to request you, Dr. Shivaram and Dr. K.B. Ramesh, please ask your scholar students. If you have time, then please ask them, because Professor Hugh Wang is a renowned researcher. He is a editor of many transactions, as well as is working in core research area, contextual probability and neighborhood counting. The title of the talk is Contextual Probability and Neighborhood Counting. So if you feel that it can be useful for your scholars, so please forward. I've invited all of you, but please ask your scholars, or you are also invited to join the talk.
Thank you, sir. Sir, Dilip sir, one question, one clarification.
Yes, please.
Sir, you said for this best paper award, is it required to, can I talk to Shivaram sir and Vivek sir, we can come to common conclusion instead of just putting from our side? Because
no, you can talk at your level, but it's an individual assessment.
That will be.
Yeah.
No, let us come to common kind of things.
Yes.
No, that is your.
Yeah, you can
whatever
talk, but normally you can probably you may have received a Google sheet for that evaluation.
We have received it. So to make it very effectively one common conclusion, so without any confusion, so I thought maybe I don't know.
Okay.
So whatever you say, we follow.
No, you are free because you are part of this conference, so you know each and every process, how we are doing, how fairly we are conducting each and everything.
It's okay, fine.
Actually, I have submitted my response.
Then fine. If that is the case, then
I thought of it supposed to go individually. Even your
That's why.
No, what
you
I
can
have done, I
talk,
have
but
noted
your means there should be in place of discussion. It should be your independent.
Okay. No, I have noted on the paper. Only I have to enter. I have to enter into the portal. That's it from my side.
And you all are also requested to join the validatory session.
Yeah, thank you.
I know it is very difficult to spare time for each and every event, but I would like to request for 2 events at least, especially Vivek sir, from you.
Yes, sir. I need the link if you have the same link.
If you have received this email invitation, then everything is available in the invitation. You simply click and join whatever any session or validatory keynote and inaugural. There is a single link, and for parallel session we have mentioned the session number. So by simple single click, and I also invited through Google Calendar, so it will remind you. So I would like to request to join these 2 programs.
I will be there with my all scholars.
Yes,
I will be there definitely. I sure.
So kind of you, Shivram sir, you are also requested.
Yes, sir. Thank you, sir.
You are also we are inspired by your work, and sometimes Professor Pachorin will discuss about your work. You are doing very beautiful work, core research, and really we are impressed with your work. And thank you very much. You are also organizing a very good conferences, reputed conferences this year also.
Yes, sir. Thank you, sir.
So I received your invitation, so we'll try to help in best possible capacity. Okay.
Yes, sir. That is required.
Thank you very much. Thank you, Sonal ma'am, Venkatesh.
Thank you.
And all other presenters. Yeah. Thank you very much.
Thank you, sir. Thank you.
Okay. So we can conclude. Okay.
Yes.
Thank you.
So Venkatesh,
Yes,
now
ma'am.
I think we can end the meeting, and
Yes,
I'm leaving.
Yes,
because I have to coordinate another session. Right?
Yes, ma'am. Sure, ma'am. Sure.
Okay.
I'm just
Okay.
closing this.
Yeah. Bye.
Bye, ma'am.